Good day everyone. Today we would like to present about business analytics, which is technique and best practice to implement in a project based on the business analytic life cycle. So this project will be presented by me, NURUL and Nur ADIBA ALYA, AMYLIA Natasha, Nur AISYAH, and also Shen John Kennedy. So our analysis is based on the complete journey data set, which is you can see the link, which capture a full year of grocery transaction from nearly 2,500 frequent shopper household. By tracking every purchase across all categories, this data gives us a complete view of household spending behavior. For the data extraction and exploratory data analysis, to turn this raw data into insight, we convert the file into CSV format and use W to build the interactive report. So the primary goal for the data analysis is we want to identify the most effective marketing campaign, most and least frequently purchased item, and buyer behavior through most popular coupon redeem. So as you can see for the first chart, we use horizontal bar chart to rank the total sale value by campaign. You can see clearly that campaign 18 and also 13 are our powerhouses, each generating over $3 million. So for the recommendation, we can recommend the business to use this structure, which is campaign 18 and 13 as the primary template for the future plan. So for the next one, we utilize another horizontal bar chart to compare the campaign type, which is type A campaign achieve the highest engagement with 2,000 redemption. Based on this, we suggest focusing our budget on the type A and B structure while reviewing or discontinuing type C, which show the lowest impact. So next, let's look at the timing and also product. We use a line graph to track the total sale value over the transaction time. The trend show that revenue peaked in the month May and December due to holiday demand. However, we notice have the consistent dip in February and September. So the recommendation we can make is to deploy our high performing campaign format during the specific month, such as February and September, to stabilize the annual cash flow. For next, we visualize our inventory performance using two different charts. The first one is tree map. It's highlight our most purchased item. As you can see, the largest and also darkest green block are fuel and also safe drink, which act as our primary trip drive. Beside that, we use a ranked bar chart to list to most purchased product, which is the item like Michelin Scroton and also Easter lilies, sit at the very bottom. So the recommendation we can make is to ensure flawless management for the top steppers while using specialized marketing to help customers discover these lower performing categories. And the last one, we analyze who is actually using our coupon. So we use multi-line time series chart to track monthly redemption count, filter by household composition. So as we can see, the green line represent household with 2 adult and no kids, which show the highest engagement throughout the year. And conversely, the orange line show that the single parent household consistently show the lowest responsiveness. So this is a massive growth opportunity. By tailoring future campaign content specifically for like single parent, we can capture a significant portion of the market that we are currently missing. So next, we move to the data warehouse design.
Okay, so to keep our analysis organized, so we build a star scheme. So think of the fat sales table as our headquarters, which is where all the big number like sales amount and quantity is live will be in there. And also we also put the foreign key of each of the dimension. So this fat sale will be connected into the 4-dimension table, which is product, transaction, promotion, and the time. So this setup is great because it makes our query much faster and also allow us to build those smooth interactive reports that you see in the tableau. So before we could dive into the visuals, so we had to clean up the data first using the Python and also Panda. So we didn't just move the data around, but we actually made it better by creating the new category like the time segments to see where the people like to shop. Once everything has been polished, we export it all, the CSV file, to feed directly into our visualization tool, which is Tableau. So first of all, we go for the customer demographic. So who is exactly shopping with us? So we found that the married household are our biggest fan, which is buying about 1.2 million units. So that is quite a bit more than our unmarried customers. So, and also about the money wise, our sweet spot, which is the middle income family making between 35K and 99K. We also noted that sales are highest for the couples with a one child or no kids at all, and the number actually starts to drop as our families get bigger. So moving forward on this part, this middle income couple are definitely our key target. Now, for the time and seasonality, so as you know that timing is everything. So not surprisingly, sales go through the roof in the December because of the holiday. While for the February, it tends to be our slowest month. So, and also about the grocery, we can see that the grocery are the steady hitter, which is they sell well at all year long. However, we see some interesting trend as well. The chef Shopee peaks in the summer, while things like the produce and also drug GM really pick up in the last few months of the year. So right now, our goal should be to time our big promo to match this seasonal wave. And lastly, let's we talk about what actually gets people to spend money. So as you can see that type A campaign are the clear winner here. So the secret sauce is about the personalization, which is we send a people coupons for the thing that they actually like works way better than just sending our generic offer. So we also found out that the afternoon is the most popular time for the people to shop. So the winning move is that simple. We need to stick with the personalized type A offer and send them out when people are already active in the afternoon and also evening.
So now let's move on to another part of the project, which we will focus on customer churn prediction using a predictive analytic approach. So the objective is to identify customers who are likely to stop engaging, so the business can take action before churn actually happens. So to ensure a structured analysis, we follow the business analytic life cycle by using RapidMiner for data preparation, model development, and validation. So our main task, as you can see in the slide, our main task was to transform transaction level data into a customer level data set that can be used for predictive modeling. This involves behavior aggregation, RFM, using RFM analysis, defining a churn label, selecting appropriate features, handling class imbalance, and comparing multiple machine learning models. So let's move on to the behavioral aggregation first. Because the dataset is transaction-based, we first aggregated the data by household ID using the RFM framework, which essentially measures how long it has been since the customer last purchased, frequency captures how often they shop, monetary represent how much they spend. So this step converts raw transaction data into meaningful behavior indicators for each customer. So let's move on to the churn definition. So since churn is not directly available in the dataset, we derive the churn variable based on an assumption. We assume that customers who made no transaction within the last 90 days are considered churn. So to do this, we use 1 October 2017 as a reference date, and then we calculated the number of inactive days for each customer, and then customer with more than 90 inactive days were labeled yes for churn, otherwise we will label as no. So this assumption is clearly stated to ensure transparency and consistency in the dataset. So the next one is for the feature selection. So after defining the churn, we carefully selected our input features. To avoid data leakage, the variable days inactive was excluded from model training because it was directly used to define churn. Instead, we trained our model using only demographic features such as income and household size, behavioral features from the RFM analysis. So these will ensure the models learn real customer behavior patterns. So the next one, we will move on to class imbalance handling. Okay, so during exploration, we identified a severe class imbalance where only about 5% of the customer were churners. This caused early models to fail in detecting churn cases. Therefore, to address this, we apply SMART, which synthetically oversampled the minority churn class. Importantly, SMART was applied only to the training data And then the test data will remain untouched. So this will preserve the validity of our evaluation. So before I explain further, I pass to my friend about the result. This is how we are developing the models. This slide will show our actual rapid-minded implementation. So here we design the main process flow where the dataset is split into 3 parallel pipelines, each representing a different model, which we use decision tree, naive Bayes, and random forest. And then each pipeline is run in tenfold cross-validation, ensuring the fair comparison. And then the next slide. And then inside the cross-validation process, which I mentioned before, SMART is applied only during the training phase, while testing is done on original unseen data. So this data will prevent data leakage and ensure that scientifically valid evaluation. So I will pass to Amelia for the next explanation.
Alright, so here we can see a sample output from the random forest model. So each customer is classified as either yes, meaning at risk of churn, or no, meaning they are still active. So in addition to this prediction, the model also provides a confidence score between 0 to 1. So this confidence score is very important because it allows the business to prioritize customers who are more likely to churn instead of treating all customers the same. So next we compare the performance of 3 machine learning models, which are decision tree, naive Bayes, and also random forest using accuracy, precision, recall, and area under graph (AUC). So while accuracy is generally high for the most model, it's not the most important metric in this case because the dataset is highly balanced. Only about 5% churnness, therefore precision, recall, and AUC give us better understanding of model performance. Alright, so looking at the decision tree model, it shows a relatively balanced performance with moderate recall and precision. This means that it can identify tuners reasonably well, and the result can easily to interpret. However, compared to random forest, it is less cost efficient when used for real business decisions. Next, for the naive Bayes model, although it has extremely high recall, meaning it detects almost all tuners, the precision is very low. So this indicates that many loyal customers are incorrectly classified as tuners. So in a real business scenario, this would lead to a high operational cost because retention offers would be vested on the customer who are not actually at risk. And finally, the random forest model will provide the best overall performance because it achieves the highest accuracy, the highest precision, and the best AUC value, which shows that the strong separation between churners and non-churners. Although its record is a little bit lower than naive Bayes, but the predictions are more reliable and practical for business use. So based on this evaluation, we selected random forest as the final model because this model minimizes unnecessary actions toward loyal customers, support cost-efficient retention strategy, and enables more targeted decision making. And overall, it provides the most reliable balance between predictive performance and real-world business impact.
And now I will be presenting on the recommendations for the CEO. So the first recommendation would be to have proactive customer retention. So this is to implement a data-driven proactive customer retention program using churn prediction, as we mentioned earlier. So this random forest churn prediction could be used in order to create a much more higher segmentation of customers into risk levels. So there will be high risk, which is more than 70% for high value interventions, and also medium and low risk for automated low cost engagement, just to ensure they are not churning. And the impact will be lower churn rate and reduced retention costs and higher customer lifetime value. On to recommendation 2 is personalized marketing via RFM. Adapt RFM-based personalized marketing instead of mass campaigns. Use RFM segmentation to classify customers such as champions, loyal, at risk, hibernating, and this to tailor the promotions to give rewards to those who are high value and to win back those who are inactive. So the impact of these are to ensure higher marketing ROI, returns, and also the increased repeat purchases and also the loyalty. On to the third recommendation is to establish business analytics as a core strategic function. So essentially, having strategic investment would be to create a dedicated analytics unit, to hire a data scientist with machine learning and data mining skills, and to upskill business users in data literacy. So the impact will be faster decision making, sustainable competitive advantage, and long-term operational efficiency. Okay, for the conclusion, business analytics is a strategic investment and not a cost. So predictive analytics supports smarter business decisions, and for us enable reliable trend prediction. RFM enhances personalization, and investing in analytics talent ensures sustained success. That's all from us. Thank you.